Hetvi Shah, and in this video I am going to talk about line coding schemes used for digital transmission. Here we are going to talk about what are line codes, flowchart, C-code showing different line codes, explanation about bandwidth and outcomes. What are line codes? Line coding is the process for converting digital data into digital signal. Digital data is found in binary form. It is represented internally as series of ones and zeros. Digital signal is denoted by pixel signal, which represents digital data. There are 5 kinds of line coding systems, that is unipolar, polar, bipolar, multilevel and multi-condition, from which we are going to study about unipolar NRZ, polar NRZ, RZ, Manchester and differential Manchester, bipolar AMI and pseudo-ternary. Now we will study the flowchart. When the process starts, user will enter some 8-bit binary input. So the for loop will work till 8 bit, means for loop will work 8 times. This binary data will go into NRZL, NRZI, RZ, AMI, Manchester and differential Manchester. If the input is 0, then this process will occur, and if the first input data is 1, then this process will occur. Similarly, for every bit there will be some kind of processes. Here T represents true and F represents false. After this process is executed, it will go to print. Here a line will be printed, either a horizontal line or a vertical line, depending upon the processing. And when the 8-bit will get over, this loop will get over and process will go towards end. Now we will study the code for line codes. Here some of the header files I have used is standard input output, console input output, graphics.h and dos.h. One of the UDF is word swap. At this position I have initiated the graph. Now we will study the graph for polar RZ. Polar RZ means written to 0. Here the signal goes to 0 in middle of each bit. It remains there until the beginning of next bit. So user will enter some 8-bit binary data. If first bit is 0, then this process will occur. First a vertical line will appear, then horizontal line and again a vertical line. And if the first bit is 1, then first vertical line towards upward, then horizontal line and then again a vertical line will appear. Now here the C, the variable which I have used, that will count the changes, number of changes that occurs during the seconds. Next is NRZL, polar NRZL. Here the user will enter 8-bit binary data. If the first bit is 0, then it will go into the F loop, where first a horizontal line will appear and then a vertical line. In NRZL there will be plus V voltage if it is 0 and minus V voltage if the input data is 1. So if it is 1, then it will go into the else loop. Here D counts the number of changes per second which occurs during the waveform. Next we will study is Manchester. Here if the input bit is 0, then it will go into the F loop here. In Manchester, if it is 0, then a waveform will be somewhat like Z, and if it is 1, then it will go into the else loop. And in 1, it will be like somewhat like inverted Z. Now we will see some of the examples and I will run the code. Here first we have to enter 8-bit data. So we'll enter 1, 0, 0, 1, 1, 1, 0, 1. Now this is showing a waveform for polar RZ. Here there are 16 changes per second. You can count the number of changes occurring. In each bit there are two number of changes occurring. So total 16. Next is NRZL. Here 4 changes per second is appearing. Then Manchester. Here 12 changes per second. AMI 6 changes per second. NRZI 4 changes per second and differential Manchester 14 changes per second. Now what this changes per second denotes? Changes per second denotes the bandwidth. For differential Manchester, polar RZ and Manchester, there will be highest bandwidth because number of changes occurring per second is highest. So first polar RZ is having the maximum bandwidth, then differential Manchester and then Manchester. But for NRZI and NRZL, there will be lowest bandwidth required. For AMI, there will be moderate bandwidth required. Now we will study some more examples to know how this changes per second is related to bandwidth. Now we will input some data like 1, 1, 1, 1, 1, 1, 1, 1. Still we can see that polar RZ is having maximum bandwidth 16 changes per second. Then differential Manchester and Manchester is also having highest bandwidth, that is 16 and 9. But again for NRZL there is 1 change per second. So here we can conclude that NRZL will be having the lowest bandwidth. Polar RZ is having the highest bandwidth. From two of this example we can say that AMI and NRZI is having moderate bandwidth, but polar RZ and NRZL will be having the highest and the lowest bandwidth respectively. Now the other example where every bit is 0. When every bit is 0 for polar RZ, it is again 16 changes per second, differential Manchester 16 changes per second, and for Manchester it is 15 changes per second. But for NRZL, AMI and NRZI, it is 1 change per second. So finally from all the 3 examples, we can conclude that polar RZ is having the maximum number of changes per second. And most of the time it is 16 changes per second. So polar RZ is having the maximum bandwidth. Next is NRZL. From all the 3 examples, we can say that NRZL was having the least bandwidth, that is 1 change per second or 4 change per second, like that. So we can say that NRZL is having the least bandwidth, but AMI and NRZI can vary between lowest to moderate, but it will never go for the highest bandwidth. It will vary from lowest to moderate. So Manchester is also having highest bandwidth, but sometimes it can vary depending on the bit you are entering. Outcomes from the software coding. From this project, I learned many things. I learned the use of graphics in C language. I learned more about digital transmission and learned many of the line coding schemes, how they differ from each other. I learned about the bandwidth And we talked about polar RZ that is having the maximum bandwidth and NRZL that is having the least bandwidth. I learned how to make videos with animation. Some of the apps or the software I use for animations are Powtoon.